Okay, this is your midterm review, and there are going to be a few more. This is going to closely mirror number 17 in your notebook. There are, however, going to be a few on here that I'll talk to you about in class, but you're going to be responsible for. Just a few, though. Example, Ernie walked 1/3 of a mile in a 15th of an hour. How many miles per hour does Ernie walk? Miles per hour is the same thing as basically what we've learned to be a unit rate. And anytime we're trying to find unit rate, we're always going to put distance over time. Now, even if we don't have distance and we're dealing with time, we're looking for the unit rate, that will also always go over time. So we may be talking about how many hot dogs I ate per hour or something silly like that. Well, that something is going to go over time to find the unit rate. Well, and of course we have that here. We have the distance, which is 1/3 of a mile, over the time, which is 1/15 of an hour. Now keep in mind, I may be asking you about feet per second or yards per minute or something like that. It's not always going to be miles an hour. And then, of course, this means, because top dog will go first, and division order does matter. I got 1/3 divided by 1/15, which turns into, after we keep, change, and flip or multiply by the reciprocal, we've got 1/3 times 15 over 1, which equals 15 over 3, which when you divide that out will equal 5, or 5 miles an hour. Now remember, the units are important. Now we have the same one. Now this is in a little bit different order. We have the hour first, or the time first, and then the miles. But the same concept still applies. We still have distance over time. 1/6 over 1/18. 1/6 divided by 1/18. 1/6 times 18 over 1. We keep, change, and flip, which means 18 over 3, which equals 6, for 6 miles an hour. And keep in mind, I'm going to be going fast throughout this video. And all you have to do is just rewind it and look at it again. A submarine at an elevation of 75 feet or negative 75 feet rises 65 feet. What is the elevation of the submarine after it rises? Excuse me. Well, we ask ourselves first, where did we get started? And we're at negative 75 feet, or basically 75 feet underwater. That's our elevation. So we say 75 or negative 75 plus 65. Now, why do we say plus 65? Because we rose, or it rises 65 feet, which indicates addition. Well, luckily we have addition here, and we can use the little song I taught you. It's same signs add and keep, different signs subtract. Take the sign of the farthest number, then you'll be exact. Well, is this same signs add and keep, or is this different signs subtract? Well, this is a negative and this is a positive, so we're going to subtract. 75 minus 65 equals 10. And we're going to take the sign of the farthest number, and what I mean by farthest number is the one farthest from 0, which will keep the negative sign. It will be negative 10 feet. And if you draw a picture out, you'll see exactly what I'm talking about. Logically, it should make sense to you that you end up at negative 10 feet, or basically 10 feet under the water, whereas before you were 75 feet under the water. Same thing here. We have to ask ourselves, where do we start? Now, if you're not careful, you're going to read this. You're going to say something silly like 18 minus 60. Okay? But we got to ask ourselves, where did we start? And we started at an elevation of negative 60 feet. And I'll read the question just to make sure you understand. A fish dove 18 feet from an elevation of negative 60 feet. What is his elevation? Or I should say new elevation. Well, we started at negative 60. And then we went down, or dove, another 18 feet. So that indicates subtraction. Well, that same signs add and keep song does not work with subtraction. So if you cannot logically figure out from this that the answer is negative 78, you can use those tricks I taught you. And when we have subtraction, we have to keep, change, and flip. Basically, we said we're going to keep the negative 60, we're going to change the minus sign to an addition sign, and we're going to change that 18 to a negative 18. Now we have addition, and we can apply that song. And it just so happens that this is same signs add and keep, which means we're going to add and keep the sign. So all we do is say 60 plus 18 is 78. And since these are both negative, we're going to keep that minus sign. So our answer is negative 78, and I should have put feet on here. Negative 78 feet. Number 5 is a little bit more complicated. We have a map that has a scale of 1/4 of an inch equals 15 miles. We do that obviously because we can't make a map as big as the actual terrain, so we have to shrink it, and we have to represent that with a smaller size. So for every 1/4 of an inch on the map is 15 miles. The distance between two parks on this map is 1.5 inches from one part to the other. How many miles apart are the parks? Well, what you have to ask yourself is how many quarter inches are there in an inch and a half? And if we were dealing with a half inch and 3.5, we would do the same thing. So basically what we have to do here is divide this 1.5 inches by the quarter inch. And here we're going to change it to an improper fraction. And then we're going to keep change and flip or multiply by the reciprocal, which is going to give us 12 over 2, which is going to give us 6. Now you're not done there. That's how many quarter inches there are between these two parks. Well, if there are 6 quarter inches and each one of those is 15 miles, all we would do is simply multiply 6 times 15 to get 90, and that will tell us that the parks are 90 miles apart. Now, you have to be careful on number 6. When you get these on a standardized test, they're going to say which expression is equivalent to this one. Okay? And it's not going to say simplify and factor. I'm just giving you that as a hint, but on the midterm and on a standardized test, they will not say that. So basically, you're going to have to look at the choices available to you. Most of the time, you are going to simplify and factor those. And in this case, what we need to do is first, we have to simplify. We're asking you to do 2 things here, simplify and factor. Well, if we simplify, we can add 14x and 7x for 21x. And then y, which is the same thing as 1y, and 6y to equal 7y. Well, we simplified, now we have to factor it. And what we have to ask ourselves is, what is the biggest number that will go into both of these? It has to be the biggest one, not just any number. Well, it just so happens that it's 7. Okay, so we basically put a 7 on the outside of a parentheses here. And then we say 7. How many times will 7 go into 21x? It will simply go in there 3x times. We just use the coefficients and keep the variable. Well, same thing. How many times will 7 go into 7y? It'll go exactly y times. And then if you multiply this out, you will get 21x plus 7y. Number 7. Jerome earns $380 a month plus $19 for each bike he sells at the bike shop. Well, this month he wants to make $700. What is the least number of bikes that Jerome can sell to reach his goal? We can if I asked you how many bikes does he need to sell, well, you could say, well, if he sells 1 million, he'll certainly make his goal. But keep in mind, I'm asking you for what is the least amount of bikes he can sell. And what you need to do is set this up as a 2-step equation. Just like we've done toward the beginning of the year, we have a constant here, which is $380. And then we have a variable, 19, which is the coefficient times the number of bikes he sells. For $19 for every bike he sells, plus $380. And then we have to set that guy equal to 700 to see how many bikes we're going to need to sell. Okay? Well, first, it's always easier to deal with addition and subtraction. And we have a 2-step equation which we have to solve for. So we're going to subtract 380 from both sides and end up with 19b equals 320, because 700 minus 380 is 320. Now we've got a 1-step equation. And we're going to divide both sides because we're trying to get rid of, we're trying to get b by itself. We have to ask ourselves, what is happening to our poor little b? It is being multiplied by 19. How do we undo multiplication? Well, we divide, or the opposite of multiplication is divide. So we divide both sides by 19. And that brings us over here. This will cross out here. Those two 19s. And then we come over here, and if we divide this out, we get 19.8 ... You get a bunch of different numbers there. You're thinking, Mr. Kent, why are you giving me this long problem? This is going on and on forever. Well, what you have to understand is that we can't sell 0.8 of a bike. Well, do we round up, Mr. Kemp, or do we round down? We have to sell the 17th bike because 16 bikes won't be enough. If you plug 16 back into this equation or simply multiply it out with this word problem, you won't have $700. So we have to sell the 17th bike to make at least $700. And this is what we call an inequality. Even though I really haven't taught you that way, I haven't taught you the correct symbol, which would look something like this. We have to use our common sense and say, hey, look, how many bikes do I actually need to sell? What is 6 and 4/11 written as a decimal? Well, we're going to keep the 6. And all we do is simply divide the top by the bottom in the fraction to figure out what the decimal equivalent is. And if you take your time and divide this out, you'll get 36, 36, 36, 36 repeating. Well, as we know, if whatever repeats, we put a line over. If it was just a 6 repeating, we would just put the line over it. But in this case, it's 36, 36, 36 going on and on forever and ever. Amen. We just put the line over the 36. I'm not going to spend too much time on number 9. All you really need to do is cross multiply and see if they equal each other. If you want to take your time and go back and pause this, you can. But these, A was not, B was, C was not, and D was not, because when you cross multiply, those answers did not equal. A weather balloon at an elevation of 85 feet falls at a constant rate. The balloon reaches the ground in 17 minutes. What number best describes the balloon's elevation change per minute? And we're going to assume that it falls at a constant rate like the question says here. We simply divide -78, which is how many feet it fell, by the number of minutes. And this will be, remember again, distance over time. And we get -5 feet. Remember, the answer will be negative. Number 11 is just a simple algorithm, or basically just a simple problem. If we cannot logically figure out that the answer is 18 or -18, we simply say same signs, add and keep, different signs, subtract. This is a different sign subtract problem. Take the sign of the farthest number, which is -34. What I mean by that is that number is the farthest from 0. Our answer is -18. We skip 12. Lola owes her sister $57.50, but she gave her back $12.50. What number best represents her debt to her sister after she repaid her that $12.50? We simply set that up as what she owed her before, and debt is almost always represented as negative. -$57.50 plus $12.50. This is same signs, add and keep. Different signs, because this is a negative, this is a positive. Different signs subtract. So we're going to say $57.50 minus $12.50 equals 45. Take the sign of the farthest number, then you'll be exact. -$45. I had to change number 14 because I made a little bit of a mistake on your worksheet. We're just going to assume that it was 9 hours. As a cold front moved in, the temperature dropped 4 degrees each hour for 9 hours. What was the total temperature change? We simply multiply -4 times 9. A negative times a positive is always a negative for -36 degrees. If you want to be cool and stay in school, learn your divide and multiply rule. Same signs, answer is positive. So if it's a negative and a negative, the answer is going to be positive. It's a positive and a positive, the answer is going to be positive. Different signs, answer is negative. If you want to be cool and stay in school, learn your divide and multiply rule. Same signs, if you're multiplying, that is, the answer is going to be positive. If the signs are different, the answer is going to be negative. Go back and watch video 1. Hopefully most of y'all, video 1 and video A, hopefully most of you guys have done that already. Katrina's ski boots cost 15% more than her skis. Her ski boots cost $287.50. Write an equation that can be used to determine the cost of Katrina's skis and what is the cost of her skis. Well, basically, what we're saying here is Katrina's ski boots cost 15% more than her skis. So what we need to do is find out what her skis are. Let me start all over. Her ski boots cost 15% more than her skis. If her ski boots cost this much, we can simply use a variable and say her skis plus 15% of her skis equals the cost of her ski boots, which is $287.50. So her skis plus 15% of her skis, and how we're doing that is 0.15, the decimal equivalent, times her skis equals $287.50, which is her ski boots. Or once you get that, I don't know how you're going to see it on a standardized test. I don't know if you'll see it S plus 0.15 S, or if you'll just see it 1.15 S equals 287.50. Either way, you can simplify this to this. 1.15 S equals 287.50. And this is a one-step equation. Simply divide both sides by 1.15, and then you'll get $250. That is, again, another one you may have to go back and watch several times, because that one is difficult. This is a simple algorithm. We're going to change this to an improper fraction. 3 times 6 plus 1 equals 19 over 3. 4 times 2 plus 1 is 9 over 4. Then we keep changing flip. Multiply straight across and get 76 over 27. We simply put the top dog in the house here, and it will go 2 times with a remainder of 22. That remainder goes on the top fraction. The denominator will stay the denominator on bottom as 27. 2 and 22 over 27. Again, we have a distance over time here, and logically it makes sense that that the miles would be divided. We simply say 160 over 1.5. You can do it as a fraction if you want. Or you could simply say 160 divided by 2.5. Remember, I told you need to start memorizing these simple fractions: 1/3, 1/4, 3/4, and so on. Well, we can't divide by 2.5. We have to move the decimal over, and we have to do the same thing in the house if we did it on the outside. And if you divide this out, you'll see that it's 64 miles per hour. Now, number 18 is one you might have to watch several times because this one is difficult. A jacket that regularly costs $70 is on sale for $56. What is the percent decrease in the price of the jacket? Well, first we have to find the cash discount by saying 70 minus 56 equals 14. In other words, we got $14 off. And you have to ask yourself, 14 is what percent of 70? And you do that simply by, and if you want to take a shortcut, you can simply divide 14 by 70. Or you can set up a one-step equation and say 70 times something, or times some percent, in the decimal form will equal 14. You divide both sides by 70, like we have here, and you're going to get a decimal, 0.20. Well, the percentage equivalent, you'll have to move the decimal 2 times for 20%. Emma earned $170 at her part-time job. She also received a bonus of 35% of her salary for some extra hours she worked. How much did she earn in all? Well, basically we're saying, well, she earned $170 plus 35% of $170. So we can do this 2 ways. We can simply say, well, we know we're going to have $170 plus 35% of it. To find 35% of $170, we simply multiply by the decimal equivalent, which is 0.35, and we get $59.50. Well, that's the additional amount we had, not the total, so we simply have to add that to 170 and get $229.50. Another way to do it, which you're going to learn later on, I've taught you this year, but you're going to have to rely on this a little bit more as you get older, is to simply say 170 times 1.35. 1 being for the original 170, 100% of that, plus the additional 35%. Either way you do these, this takes a little bit longer. If you're more comfortable with this, I don't have a problem with that. This is a little shortcut. So basically find 35% of 170 and add it to 170, and you'll be good. Number 20, the water level of a full tank changes by the same amount each day when it leaks. The total change in the water level is 910 gallons over 14 days. What was the daily change? What was the daily change in the water tank? Well, you could logically say, well, we're going to take the negative amount that it fell, 910 feet or gallons. Oops, I put the wrong unit here. I did that in class too. Forgive me. And simply divide it by the number of days. Isn't this a something over time? we're looking for unit rate here, even though I haven't asked you for a unit rate. That's basically what we're looking for. 910 divided by 14 is 65. So basically what we're saying is it is moving or dropping 65 gallons a day. And if you turn around and multiply 65 times 14, you will get 910. But remember, it is negative because that's what we're losing. Here we simply set this up like a two-step equation. A home improvement store charges $40 to rent a small truck, plus $5 per hour. How much will it cost to rent the truck for 8 hours? Well, once we set up our two-step equation or expression and then we solve it, we can basically figure out how much it will cost for any given different number of hours. 1 hour, 2 hours, 20 hours, 50 hours, it doesn't matter. We can just simply fill in the missing variable here. Well, we've done that here, 40 for the $40, plus 5 times 8 for 8 hours, which equals 40 plus 40 equals $80. Mr. Smith buys 3.5 pounds of grapes for $2.10. What is the unit cost? Well, what you need to simply do is, if you're having a hard time figuring out what operation to perform, say Mr. Smith bought 2 pounds of grapes for $10. You can easily figure out the unit rate there by dividing 10 by 2. Most of y'all could do that in your head in your sleep. Well, when you get these crazy numbers, though, you kind of tend to forget that. So fill in easier numbers to figure out what operation to perform. Just as we said 10 over 2 here, we can easily say, well, this will go over this. And you could do this one of two ways. You could do it as a fraction, both of them as a fraction. I would convert that 3.5, though, to 3.5. Divide it out, you'll get 0.6, so the unit rate will be 60 cents. Now, a shelf is 31.5 inches long. Allison is setting her model cars front to back on these. Each car is 3 3/4 inches long. What is the greatest number of cars she can place on the shelf? The greatest number of cars she can place on the shelf. We're simply going to divide the shelf size by how big the cars are. If I were you, I would convert this to a decimal and make it much easier. You can do it this way. I don't have a problem with that. They both will be right if you do it right. This will have to change to 375, and this will have to change to 3150, because if we move it twice out here, we move it twice in here. If you do the math on this, you get 3.4. Well, 8.4. Well, 8.4 is too many. You're going to have one on each end that's going to be kind of over the edge a little bit. That's too many. All right. What they're asking is, what is the greatest number of cars she can place on the shelf? So the answer will be 8. She can only fit 8, and she doesn't want the cars to be over on each side. Zane and Shelby's grandfather is 5 times as old as the total, so 5 times the total of their ages. And then it tells us her grandfather is 75. Is almost always indicates that you're going to have an equal sign and then the answer. And then it tells us that Shelby is 7, so we're going to fill that in for the S variable here. So we have 5 outside of 7 plus Z equals 75. Now normally what we would do is just add these two up. But we can't add 7 and Z because they don't have the same variable. So we're simply going to distribute this 5 throughout here and get 35 plus 5Z equals 75. And now we have a two-step equation. Well, we always do addition and subtraction first to make it easier. We're going to subtract 35 from both sides, and we're going to end up with 5Z equals 40. And then again, we're going to divide both sides by 5 to get the Z by itself. So these will cross out. 40 divided by 5 is 8 for 8 years old. Again, you may have to watch that one several times to make sure you pay close attention in class, because that one, again, is a hard one. You've got these boards here. We want to know the one of them's 2.5, one of them's 4 3/4, one of them is 3 1/4. What is the total length? You're simply going to add those up. You're going to have to convert these to improper fractions. If you don't do that, you can convert these to decimals. That's perfectly acceptable. You can do that too. But I've done it as improper fractions here. 5 over 2, 19 over 4, 13 over 4. I have to find the common denominator when I'm adding, and luckily this one's easy. It's going to be 4. And these two are going to stay the same. But I do have to say, hey, how did I go from 2 to 4? Well, I multiplied by 2. I got to do this, I got to do the same on top. So I'm going to add this up. It'll be 42 over 4. And if you do that with a decimal, it's going to equal 10.5. If you do it as a fraction, it'll be 10 and 4 over 2, which simplifies to 10 and a half. Again, you're going to set this one up like a two-step equation. Angie is saving money to buy a new tennis racket that costs $198. The total cost is $198. If she saved $26 so far, and she works $17, she earns $17 each week, or saves $17 each week, we can say 17W for 17 times the number of weeks, plus the 26 she's already saved, to equal $198. What is the least number of weeks that she will have to save to buy the racket? The least number of weeks. Well, we simply solve this like a two-step equation. We subtract 26 from both sides. We end up with 17W equals 172. We're going to divide both sides by 17 and get an answer, a really funky looking answer, 10.1 and a bunch of different numbers. Well, that tells us that 10 weeks is not enough money, but 11 weeks will do the trick. And again, that's an example of an inequality. We're going to simply set this one up, number 27, as a proportion. And make sure you label them like I've always taught you. The milk, we'll put the milk on first. It doesn't matter to me which one you put on first, but 3 1/4 cups of milk over 9 servings. X cups of milk over 12. We would simply cross multiply. If you're having a hard time with this one, once you go back and pause it and take a look at the math that I've done here, your answer will either be 4 1/3 or 4.3 repeating. And that's cups. That's the unit there. We are adding and subtracting expressions here. And luckily, these two are just adding. And we know they're adding by this middle addition sign. Not this one, not this one, not this one, or not this one. But the middle sign tells us what we're doing. Now, these are really simple if you're adding. All you have to do is combine like terms. If this sign is addition, that's all you have to do. When you have an expression here and an expression here. All you have to do is combine like terms. 5x plus 18x is 23x. 12y will not combine with anything, so plus 12y, and we just bring down the negative 4. Here we have to combine a little bit more. We've got 95 and 18x. We're simply going to add those together for 113x. And we can combine the 12y with the 5y. 12y plus 5y is 17y. Number 30. What is the value of the expression below when a equals negative 9 and b equals negative 8? Well, we simply fill in the variables that we know. So you're going to have 2 times a negative 9 plus negative 8 squared. Now you've got to be careful on these negative numbers when they're squared, because people always want to make that a negative number. Negative 8 times negative 8 is positive 64, because a negative times a negative is a positive. And then, of course, you have 2 times the negative 9 here, which is negative 18. So now you've got negative 18 plus 64. We have addition, so we can sing our song. Same signs add and keep. Different signs subtract, so we're going to subtract here. 64 minus 18 is 46. We're going to take the sign of the farthest number. Oh, excuse me. This is the farthest from 0. I apologize. So this is going to be a positive 46. The number of dollars in Mike's wallet is 3 more than 1/4. That could be, you could also say that 1/4 y, or y over 4. The number of dollars in Drake's wallet. Mike has $60 in his wallet. The equation below represents this situation. What does the Y represent? This simply represents the number of dollars in Drake's wallet. Again, the number of dollars in Mike's wallet is 3 more than 1/4 the number of dollars in Drake's wallet. And it simply tells you right here, 1/4 the number of dollars in Drake's wallet. That will go right here too. What is the product of -6 and 14? We simply multiply those. A negative times a negative is a positive. Number 33, this is a subtraction problem with expressions. If you see a minus sign here, it's a little bit more complicated. What you simply have to do is keep, change, and flip, which means you keep everything in the first expression the same, and you change everything in the second one. This is 4x. And once you're done with that, you're done with that. This 4x becomes -4x. This 7 becomes a -7. And you simply combine like terms in. 10x minus 4x is 6x. 11y will not combine with anything else, so bring it down here. And then bring down your -7. And finally, you're going to have one of these like this on the midterm, where they're going to ask you to write a number, sentence, or an expression. And basically what you have to do is say, well, look, we're always going to start at 0. Then what did I do? What did I do when I started at 0? Well, we added 2 here, which is +2. And then we didn't say -3. We moved to the left 5 times for 1, 2, 3, 4, 5. We moved to the left 5 times, so we would say -5. And the answer would, of course, be where we ended up, -3, which is where we had here. Or you could say 2, and you could say plus a -2. That's the same thing. Either one of those will work, and I'm not sure how you're going to see it. But say we always start at 0. I went +2, 1, 2, 3, 4, 5, -5. And when it says a number sentence, all that simply means is an expression.